Okay, I'm going to try and see if this works. This is my first movie. So we're going to try this together in class, and then you're going to watch a lot of these on your own. So what I want to do today is talk to you about the scientific method. That's going to be our first movie. And if you are on your packet for Unit 1, then you're going to look, I believe it's page 5, but I may be off on that, depending on which packet you have. And I want you to take a look at this PowerPoint. We're going to go through it together. And I'll stop and show you some things on the internet, and then you can stop the video at any time and watch it, or take some notes. And you have the blank version in your packet, so this is going to be the more note version. So the scientific method, we do it in every science class, and I'm sure you've heard of it. And it is really just a way that scientists study the world and try to make explanations about what they're seeing. And the thing I like about this is that it's really real. And the thing that I don't like about it is that I don't like that it has science in it, because I want to show you that I actually went and looked up. Let me show you this. I looked up the scientific method in everyday life, and I found just like a ton of examples of how all of you use the scientific method all the time, even though you don't really realize that you do. So here's an example on this website here from Arizona State. The scientific method used in everyday situations, such as you come home one day and your light doesn't work when you turn the light switch on. And you try various things. You try unplugging it, you try changing the light bulb, you try changing try the switch, and then finally you come to some kind of a conclusion about what's happened about your lamp. And maybe, for example, the bulb was out, or maybe the switch is broken, or maybe the wire was snapped. Lots of different things that could come out of that. But we use the scientific method all the time, in every job. Here's another one about non-scientists. Think about cooks. They have to try things out. They want it to taste a certain way, so they have to taste it. They have to try it again, maybe make a new recipe. How about writing a news story? You got to have a version, you got to revise it, you got to have somebody read it, you got to check it, and then you have to make a final copy. What about advertising? You want to sell some product, you have to try different commercials. Which one's going to work, which one's not going to work? You try it, you let the audience decide which ad they like, and then you hope that you adopt that ad, and it helps you sell products. So we're always doing the scientific method. And so if you look in Google and onto that, you'll see that. And I want you to kind of be aware of that as I keep talking here through the rest of the PowerPoint. So let me go back here to the PowerPoint, and I'll kind of keep going with this the scientific method steps. The first one is making some observations, and observations could be quantitative or qualitative. Quantitative always refers to quantity, like a number. So information like how many miles, how tall are you, anything that can be answered in a number is quantitative. Qualitative would be something like that girl right there. She's wearing a black shirt. She's wearing a yellow shirt. She has brown hair. These are all qualitative. That means that they cannot be described in numbers, but they're still good information. And we call that information data, which I'm sure you have heard of before. After that, we pose some question that we want to answer, and the question should come from your experience, like the light switch not working, and you should be curious about your topic, and you'll have a question. In every lab that we'll do, I'm going to ask that you have a question that you're answering in the lab. Then you develop what we call a explanation or educated guess as to what's really happening. It's not really a guess, but it is sort of an explanation as to what you think the answer is. Maybe why isn't the light working? So you come up with a guess. Then you design an experiment, and you try it out, and you try one thing at a time, and we call that being a controlled experiment, testing only one thing at a time. So for the light switch, you wouldn't want to turn on the light switch and change the bulb at the same time, because then you wouldn't know which one was really causing the problem. So we test one variable at a time, and the thing that you test is called the independent variable. And the thing that you measure, such as how tall something is, or how the speed of something, or whether a plant grows tall or not, that's called the dependent, what you measure. So independent's what you change, like maybe the amount of light something gets or the kind of medicine somebody gets, and dependent variable is the thing that you measure as a result of that change. And we're going to do lots of examples. Then you analyze data. We make data tables and graphs. We're going to do a lot of that. Your graphs and data tables will all have units and headings like this. They'll look very similar to these. And you have to kind of learn about different kinds of graphs, and we'll talk about those. And finally, you have to draw a conclusion. And when you draw a conclusion, you take your experiment, and you take everything that you've learned from it, and you figure out if your hypothesis was right. Was it the switch? Was it the light bulb? Was it the light lamp itself? Was it the plug? You have to kind of answer that in a conclusion, what you learned. And that's the way we do the scientific method. So I hope that this worked, and I'm going to stop this right now. Thanks, guys.